I'm your instructor, Dave Semlink from GoDigitalSA Foundation. Today we're looking at Unit 10, Radio Communication. Okay, so Lesson A will be Understanding Radio Communication. What we'll learn is how radio communication works and the radio functionality of the microbit. Okay, just a quick reminder, what is a computer? There are four main parts to a computer. The processor, CPU, memory, which is RAM and storage, or short-term and long-term storage, inputs, and radio can be an input, and outputs, and radio can be an output. So what types of computer radio inputs and outputs are there? Okay, GSM. This is how cell phones communicate. Smartphones transfer data and voice over GSM. Okay, so with your cell phone network, a cell phone talks to a radio tower, which connects you to the GSM network, which connects you to other cell phones and to landline phones. Wi-Fi. This is how laptops, tablets, and smartphones communicate wirelessly over a local area network. Okay, so with Wi-Fi, you've got a Wi-Fi router or hub, and this communicates with laptops, smartphones, and anything else that uses Wi-Fi. Bluetooth, this allows devices to communicate with each other. Okay, with Bluetooth, you can connect printers and headphones and various other things to a smartphone or to a laptop. And NFC or RFID, this allows a contactless card or tag to communicate with a computer. And it's starting to be used now with cell phones to have a cell phone connect to a point of sale terminal. Okay, so main differences between these. GSM works over long distances and in fact through the towers connecting to the rest of the network, it works all the way around the world. Wi-Fi works within about 100 meters. So it's usually within one or two rooms or offices. Bluetooth is short range, so it's also very close by. It's usually within the same room. And NFC is very close by, so normally you need to tap or be very close for them to communicate with each other. Okay, so the microbit has Bluetooth. It can communicate with other microbits and with smartphones and other Bluetooth devices. So radio communication. Radios use electromagnetic waves to send messages through the air. A radio communication system requires a transmitter to send messages and a receiver to receive messages. A transceiver is both a transmitter and receiver. GSM, Wi-Fi, Bluetooth, and NFC all use transceivers. The first radio was invented in 1894 by the inventor, Mr. G. Marconi, in Italy, and used radio waves to transmit and receive telegraph signals. Okay, so here we've got a diagram of the electromagnetic spectrum. We start off with radio waves, which are very low frequency, and they go up to high frequency and very high frequency, and then to microwaves. And microwaves are also used in a microwave oven. Then we've got infrared radiation, which is invisible to the naked eye, but you can detect it as heat. Then you've got visible light, which starts off as red and goes through the whole spectrum until you reach blue and purple. Then we've got ultraviolet, and this again is invisible to the human eye, but we know about it because you can burn your skin with ultraviolet light. And finally, we've got X-rays and gamma rays, which are very high frequency radio waves. And this is just a photo of one of the first radios. So radio on the microbit. On the back of the microbit, if you look closely in the upper left corner, there's an antenna, which is how the microbit can send and receive messages through radio waves. Okay, so it's got a Bluetooth antenna, and inside one of these chips, it's got the Bluetooth electronics, which allows the microbit to communicate with Bluetooth. Okay, programming with radio. The microbit allows you to communicate with other microbits in the area using the blocks in the radio category. The microbit can act as a sender and or a receiver depending on what blocks you use in your program. You can send a number, a string, or a string number combination in a message. You can give a microbit instructions on what to do when it receives a radio message. Okay, so in the blocks toolbox, we've got a category here, radio, and in this category we've got various blocks. And the first few here is radio send number, radio send value, where it's both a string and a number, or radio send string. So these are for sending information. And then we've got event handlers on radio received. You do something to receive a number. On radio received, this is to receive a value with a string and a number. And on radio received, received string. Okay, and so on. There will be more, and under the more drawer, there's going to be more blocks. Okay, infection simulation. We will download a ready-made program to 2 or more microbits. Okay, so we'll go to this site. Now, once the download is complete, we disconnect the microbit from the computer and connect it to the battery pack. One microbit will be our patient 0, where we'll press the A and B buttons on the microbit. The remaining microbits will initially be uninfected. Okay, so how to play? You wait for an icon to appear, then you go meet the other players and place your microbits side by side. Okay, so we have to start with all the microbits far away from each other. And then we move around carrying the microbits, and when one microbit and when an uninfected microbit approaches the infected microbit, it will receive the radio message telling it that it's now infected. Okay, and we'll see this because we'll see smiling face means that the microbit is not infected, frowning face means the microbit is sick, and the skull means it's dead. Okay, so to play the game, you keep on playing while it's smiling. When it's frowning, it's sick, and if you get the skull, then you have to sit down. Okay, so if we play this game, does anybody manage to stay healthy? If so, how? If not, why not? Well, as you can guess, if your microbit never gets close to an infected microbit, then you won't get sick. So how do you think the disease is spread? Well, in this case, they're close enough so that the Bluetooth signal can reach from the infected microbit to the uninfected microbit. And who do you think started it? It would, of course, be the infected microbit, the one where we press the A and B buttons to start. And what could we do to find out? Okay, if we start the game from scratch, we could check to see which microbit is causing the other microbits to change the icon from a smiling face. Okay, what strategies might we adopt next time to have a better outcome? Okay, if you don't want your microbit to get sick, then you have to keep it away from the one that is sick. Okay, so this game teaches you something about infectious diseases. So we've got a vocabulary for infectious diseases. Asymptomatic means someone who has the virus but is not showing outward symptoms of being sick. Carrier is someone who has the virus and can transmit it to others. Immunity is someone who cannot contact or transmit the virus. Incubation, it's the period of time between when a person contracts the virus and when the person starts to show symptoms of being sick. Inoculation makes someone immune to the virus. Patient 0, the first person to introduce a virus to a community. And quarantine, a strategy to isolate those who are suspected of carrying a virus. So what we learned, how radio communications works, and the radio functionality of the microbit. Okay, so in lesson B, we're going to explore the radio toolbox and assess our learning with a quiz. Okay, lesson B, explore the radio toolbox. So what we'll learn, programming using radio blocks to send and receive different types of data, and then we'll review what we've learned. Okay, do you know the swimming pool game Marco Polo? Okay, here are the instructions. One player is chosen as it. The it player, with closed eyes, tries to find and tag any one of the other players, relying on hearing to find someone to tag. The player who is it shouts Marco, and the other players must all respond by shouting Polo, which the it player uses to try to find them. If a player is tagged, then that player becomes it. Okay, so we will be coding a form of this game using the radio communication on the microbit. On button A pressed, the microbit will send the string Marco. On button B pressed, it will send the string Polo. The microbit will also display the strings received from the radio. Okay, your final program will look something similar to this. So on start, we'll set the radio group. Okay, the radio has got different channels. They're like different radio stations, so you have to choose one of them. And they're identified by a number, so we're just setting it to group number 1. On button A is pressed, we'll send the string Marco. On button B pressed, we'll send the string Polo. And then on radio received string, it shows the string. Okay, so if somebody with one microbit presses button A, then all the microbits should show Marco. And then if anyone presses button B, they should all show Polo. Okay, so that's the basic program. And we can modify it by adding a show LEDs block to the onStart block to show an image of the initials Marco Polo, MP. From the music toolbox drawer, drag 2 playtone blocks to the coding workspace. Drag one of the playtone blocks to the on button A pressed block and the other one to the on button B pressed block, and change the default value in the playtone block that is inside the on button A pressed block to the value lower C. Okay, so that's just so that we can hear a sound, but then we'd have to connect earphones or a speaker to the microbits. Okay, so to play, after downloading the program to the microbit, we disconnect the microbit from the computer, attach the battery pack, and then one person has to start by being it, so they can be Polo. So everyone presses button A except for the one person who is Polo, who presses button B. And so then people can walk around, each one with their own microbit, and they can try to find out who Polo is. Okay, let's open a browser and start coding. So now we're going to start a new project. We'll call this Marco Polo. Okay, so we're going to be using the radio drawer. We have to start by setting a group. So on start, we set the group to 1. On button A pressed, we send the string Marco. On button B pressed, we send the string Polo. Okay, on radio received, we'll have the received string we can display that string. So we can show the string, show the string, received string. Okay, so now we have to download this to 2 or more microbits. Clicking download. Okay, so I've downloaded it to these 2 microbits. So they have power. So if I press button A, it should send the string Marco. And if I press B, it should send the string Polo. Okay, and either one can do this. If I press the button here, it sends it to the other one. It's Marco. Press button B, and it sends Polo. Okay, so the idea is that the person who is it has to close their eyes and they walk around pressing button A, and everybody else has to press button B. When he's close enough to any person, he will get the signal from that one's microbit, and then he can tag that person, and then they become it. Okay, so that's the basic game. Okay, so let's save it and go back home. Okay, here's a second example. This is Morse code. Morse code uses dots, dashes, and stops or spaces to communicate. So you can turn your microbit into a Morse code transmitter and receiver using the radio. In this program, 0 would be a dot, 1 is a dash, and 2 is a stop or space. So in our pseudocode, if you press button A, it sends a 0, which we're saying is a dot. If you press button B, that's a dash, it sends a 1, and that's a dash. And if you press both A and B, it sends a 2, and that's interpreted as a space. So when any other microbit receives a 0, it should show a dot. If it receives a 1, it should show a dash, and if it receives a 2, it should show a stop or a space. Okay, so two people can use this to communicate with each other. So you set a unique radio group number. Okay, if there's more than one group, then the first group can choose radio group 1, the next group chooses radio group 2, and so on. And you create a secret message for your partner using Morse code, and you take turns being the sender and receiver. Senders must transmit their message using the microbit buttons, and the receiver must decode the secret message. Okay, remembering that button A is a dot, button B is a dash, and A and B together is a space. Okay, let's open the browser and start coding. Okay, we'll start a new project. We'll call this one Morse code. Okay, and we'll start by setting the radio channel to group 1. And remember, you can pick any group, but all the microbits have to be on the same group. And let's just identify the program. We'll say Morse code. Okay, so when we press button A, we want to send a dot. Which we said is going to be the number 0. And we can just duplicate this now. When we press button B, we want to send the number 1. Duplicate that. When we send A and B, when we press button A and B, we send the number 2. Okay, so now when we receive information, we need to see if it's a 0 or a 1 or a 2. So that's going to need some logic. Okay, we're going to receive a number. Okay, and then we have to check, is that a 0 or a 1 or a 2? So I'll take if, then else. We want to compare, so that's under logic. So is the received number equal to 0? So if the received number is equal to 0, then let's display a dot. And we'll display it for, let's say, 1 second. Okay, which is 1000 milliseconds. And then we'll clear the screen. Okay, now we have to see if the received number is equal to 1. So I'm going to have to add another if. And then we'll compare received number to 1. If received number is 1, then we display a dash. And we can pause for 1 second. And then clear the screen. Okay, so we're sending either a 0 or a 1 or a 2. So logically, we can say, well, if it isn't a 0 or a 1, then it must be a 2. However, because this is radio, what happens if there's radio interference or something else goes wrong and we receive something different from 0, 1, or 2? So to make sure we're receiving the right information, we'll add another else if, and we'll check to see if it's 2. So if it's a 2, then we display a space. I'll say a space is a blank box. Pause for 1 second. And then clear the screen. Okay, so if we receive something and it isn't 0 or 1 or 2, then we have a catch-all. So we say else. It's something we didn't expect, so we can show a string, and we'll say error. Okay, so we're expecting to receive a dot, a dash, or a space, and anything else will display error. Okay, let's try this. I'll save it. And then we'll try it. Okay, note when I do something, it's created a second microbit in the simulator so that we can send radio messages from the one to the other. Okay, so let's just test it. If I press A, that sends a 0, and that should be interpreted as a dot. Okay, and you see the dot down there displayed for a second, and then it clears. If I press B, that sends a 1, and that should be interpreted as a dash, which is correct. And if I press both A and B, it sends a 2, and that should be interpreted as a space, which it is. And remember, they're both running the same program, so it works both ways. On this one, I can send a dot, or a dash, or a space. Okay, so now we can send messages back and forth. Let's just see how we would use this. If we go back to our slides, let's just go back one slide. If we want to send the letter A, we send a dot, a dash, and a space. If we want to send the letter B, we send a dash, and dot, 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 and then a space. So let's say we want to send hi. Okay, hi is going to be H, which is dot, 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 and a space, and then dot, dot, and a space. Okay, so let's try that. Okay, so we wanted to send dot, 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 dot. So it's dot, 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 and then a space. Okay, so the second person should write down the letter H. Now I send a dot, space. So the second person should write down the letter I. And now they know that I've sent hi. Okay. Okay, so that's sending Morse code messages from one microbit to another. And you can use this now to send messages back and forth. Okay, we're done with this. So we'll go back home. And we'll go back to the quiz. Okay, it's time for a quiz. Okay, using the radio blocks, what information can you send to a microbit? You can send a number, a string, or a string number combination. You can also give a microbit instructions on what to do when it receives a radio message. What is the definition of string data? Okay, a word or series of alphanumeric characters. Okay, and those characters, of course, can include symbols and punctuation. Why did we have to set our radio set group block to a default value of 1? So that the microbits would all be using the same group ID number and could send and receive messages. Okay, they all transmit on a channel and receive on a channel. So you have to choose the same channel for all of them so that they can send and receive on that same channel. Why was it important to set a final catch all else clause in the conditional you used for the Morse code activity? Okay, so that it would display an error message if it received a number value beyond 0, 1, or 2. When editing code, why do we look for lines of code that repeat? To make code more efficient and to reduce the number of lines of code needed. Using pseudocode, describe what these code blocks do. If the radio receives a number greater than 11, it will display a check mark. Okay, so on radio received number, if the received number is greater than or equal to 11, then it shows a check mark. So what we learned, we programmed the microbit to send and receive different types of data. Okay, so next time the project is to make a microbit radio. So to make a microbit radio, you need to work ideally in pairs to create a project using the microbit radio. And it's good to use a technique called pair programming, where computer programmers will often collaborate on a project together. It's called pair programming. Two people work together on the same computer. One person is the navigator. He provides instructions and direction. One person is the driver at the keyboard mouse taking instruction from the navigator. They work together to ensure good communication. Okay, so microbit radio, your task is to design a microbit project that incorporates radio communication to send and receive data in some way. You can create two separate programs for the sender and receiver, or use a single program that acts as both the sender and receiver. Use strings, numbers, or string number value pairs. Your project should solve a problem or fill a need. Project examples, hey, stop thief. Design an alarm system for your bedroom that alerts you with a screen animation when someone opens your door. You can mount one microbit on your door and use the accelerometer to send a signal over the radio when it is being moved. Interactive art, create a piece of interactive artwork that receives something as input over the radio from another microbit and displays something based on that output. Project example, 3-note keyboard. Simple 3-note keyboard that uses wooden paint stirrers and copper tape to make a connection to the 3 microbit pins. When a key is pressed, it sends a number over the radio to the second microbit that plays the appropriate tone over a set of earbuds. This allows you to use each of the 3 pins on the first marker bit to play a different tone. Radio tennis. The tennis rackets alternate display a ball on their marker bit LED screen. When you swing the racket, the ball disappears from the 1 marker bit display and shows up on the other marker bit's display. Okay, project expectations. Use a design thinking approach and ensure the project meets these specifications. Use a radio to send and receive data with meaningful actions and responses for each. Use radio blocks in a way that is integral to the program. The program compiles and runs as intended and includes meaningful comments in code. Okay, so we made a microbit radio. So next time we'll be doing Unit 11, arrays. Okay, so I'll see you next time.